Let's go. Hello, my name is Brian, and I'm about to do some tiger beetle hacking. I want to tell you really quick. I want to admit that I am exhausted, physically exhausted, and I expect it to really affect my cognition. I'm probably going to be slow and zombie-like. I may find myself kind of drifting through a waking dream in the stream. And I apologize if at any time I start speaking like babbling gibberish or if I fall asleep. Just keep an eye out for any weirdness. So what we're going to do today is continue working on a Rust client for Tiger Beetle. And if you're here, you probably know, but Tiger Beetle is a financial database that goes really fast, written in Zig. It's got a bunch of clients for common languages, Node, Java, C, Python, others that I'm forgetting. And it doesn't have one for Rust, but there's some demand for Rust. So I'm trying to get a Rust client together. And the strategy we're taking is to kind of write two clients at the same time, honestly. All of the current Rust clients are bindings to a Zig client called TB client, which presents a CFFI that other languages bind to. In Rust, we're thinking maybe we don't want to do that. We want to write it in pure Rust for reasons that I forget right now and aren't important. But also binding to TB client is probably going to be easy. So we're going to do it both ways. And having two implementations, one, the working implementation, the known working implementation, will help us test the pure Rust implementation. So we got started on this yesterday, and that went pretty well. All we got really working yesterday was, building the TB client static library and setting up the Rust build script to link to it. Then we gave a little look at the client API, the CFFI API, and started sketching out a Rust API. And somebody in chat mentioned that maybe we should use Bindgen. And Bindgen is a tool in Rust that looks at C headers, maybe C++ as well, I'm not sure, and then spits out equivalent Rust code for calling that C code. And I don't usually use Bindgen. I usually write my bindings by hand, but Bindgen is popular. And it makes a lot of sense here because we might be changing the C API over time. And also, it's just a kind of cool thing to do on stream, just show how to make Bindgen work. I haven't used Bindgen in a number of years, so I'll have to learn it on stream too. Should be fun. All right, there's a question in chat what my time zone is. I'm in Mountain Time, I think. I'm in Colorado. So it's 9, a little after 9 here. Definitely going to crash as soon as we finish here. I think it'll be a short stream. Like as I said, I'm pretty tired. But let's get these Bindgen bindings working. Try to build them, see how far we can get, see how it goes. All right, got my streaming mug. Going to be taking some chugs of water to keep hydrated. I got this mug because I hope it looks good on stream compared to my daily driver water bottle. Okay, let me see. I think we can go ahead and start poking around the code, kind of remember where we are. Let's see. Here's our code. Well, this is not our code, but this is where I code. And this is kind of the stuff we did yesterday. And I want to go back to our build script because I realized after we quit yesterday that I made a bug. I want to fix that bug real quick. Should be super simple. So if you'll recall, this is the build script. And in the build script for the Rust client, we are finding the static library compiled from Zig to a C-compatible static library. And we're linking that into our Rust crate. And this is all code that does that. Here we're kind of figuring out what architecture we're targeting in the current build. And here we go construct the correct directory to go find the library. And this directory is all like Tiger Beetle specific stuff. Tiger Beetle decides that it wants to go put it in this directory and give them these names. And I can show you real quick. Here we are, Tiger Beetle source client C. This is where the client code lives for the Tiger Beetle client in Zig that's compiled to a C-compatible library defined by this auto-generated tbclient.h. This tbclient.h is generated by some custom Zig code, which I don't think I've shown on screen, but maybe we'll get to it sometime. And then this outputs code to a directory that isn't shown here, this one, lib. So within here, there are static libraries, dynamic libraries. And that's about that. So if we go over here, I'll show you where the bug is. So in our build script, when we're trying to link to some non-Rust code, we got to kind of print out these directives to tell Cargo to do special stuff. So these two things are telling Cargo that we want to look for native libraries in a directory, and we want to link to a native library that it may or may not be in that directory, but some library with this name. And then Cargo will in turn take this information and pass command line flags to rustc. But what I forgot is this third line here, this rerun if changed. This tells Cargo if some file changes that Cargo doesn't understand, it's just going to watch the file, then we need to rerun the whole build. In this case, we're saying, here's our library, the path to our library. If that thing changes, in other words, if we've done a new Zig build to create the library we're linking to, then we got to rerun the Rust build. But the thing I forgot is that libraries have different naming on different platforms. So here I've called this library lib name. This is a, what do you call it, a string interpolation, libname.a. That's how all Unixes that I know of name their libraries, but not how Windows names this library. So this is a silent bug, and that's like the worst kind of bugs. I'm okay writing loud bugs that kind of will fail loudly sometime down the line, either at compile time or runtime. But this is just going to silently not get the name correct of this library on Windows. So that's super bad. I don't like that at all. So I just want to fix this bug real quick before we do the Bindgen. All right, and to do that, we probably need to go look up some more Cargo documentation. And got to remember, my brain is going so slow. So got to go to our browser and search for the Cargo book, which is already in our history, these environment variables. And again, as I mentioned yesterday, every time I work with Cargo, just got to go read the docs. There's just too much to remember. Our environment variables down here for build scripts. Cargo is just going to tell us whether we're on Unix or Windows. And excuse me a moment. Just had to burp. Don't want to burp on stream. It's like burping at dinner. I try not to burp at dinner, but I burp so much. I'm a good burper. So CFG Unix and Cargo CFG Windows, we just check those environment variables. That'll tell us where we are. So I'm going to go back to our code. And over here, we've already collected all these environment variables, and we need one more. I'm going ahead and put them up here. Let Unix equals invar, and that was Cargo CFG Unix, I think. And again, we're unwrapping here. I don't like unwrapping. So these are always going to succeed, these unwraps, because Cargo would just be super broken if it wasn't setting these. That will never happen. And in this case, I'm unwrapping just because I'm kind of lazy and it's not worth doing real error handling. And a lot of my own code, I would do this. I would say expect dot just to get that expect method call in there to indicate like, yeah, this is going to work. and I wouldn't put any useful message in here. But production code, I think most people don't like this as an idiom. So for now, I'm just going to write unwrap. And maybe in code review, someone will complain, but I doubt it. I really don't like to see unwraps in Rust code anywhere except for maybe test cases. Var cargo CFG, I wrote window, let windows unwrap. And then down here where we were doing the rerun if changed for the library name, I want to say if, and again, Rust, I don't need parentheses around the expression head here, or the head expression of ifs and matches and such, but I've been writing a lot of Zig, so I'm just habitually doing that. If Unix, we're going to do this, and then if Windows, I don't know what we're going to, else if Windows, I don't know what we're going to do, so I'm just going to, punt that. And then I'm also going to put the final case here. Like, I don't really expect Tiger Beetle to ever be compiled for a third operating system family, but I want to cover that case anyway, and I'm going to put a semicolon there. Not necessary. A lot of places in Rust, semicolons are semi-optional, but these aren't expressions. These are really statements, so I'm going to semicolon it. All right, and we're just going to test and see if this builds and then move on. I'm in the wrong directory. Cargo check. Cargo check is just type checking. If Unix, I did this wrong. So obviously these should be bools, and the environment variables are strings. And I think what I need to do here is just see if these exist, which is, so these are result types, which can be okay or error. And I'm going to say is okay. And this is okay. I'm not just going to turn these into bools. So if that environment variable exists, it's going to be true. Real quick, I'm going to go look at that cargo docs and just make sure I'm right about that. Okay, yeah. So these are, sometimes these are not set. So I was kind of wrong with what I was saying before. Like these three are always set, but these two are not always set. Let's go type check that. Okay, and we're just going to dump this into our I'm going to type correctly, dump this into our accumulation of commits. All right, now I've got 2 temporary commits. That's okay for now. Again, I don't really care about the commit history right now. I only care about that once I'm getting closer to something submittable for a PR. Okay, so that's all good. And I've only done the type check, but I'm going to actually do a build just to make sure we're linking. Okay, and we are. And actually, I'm wrong when I say that because we're building a Rust library, and Rust libraries are not fully linked. We really have to link the Rust library to a binary before the link step actually happens. And maybe we'll do that on stream today. Maybe I'll do that right now. Let's go ahead because I just paranoid. I want to make sure it at least builds. So in our Rust, we can just put in the source directory, we can just put a main file. And we're going to need a binary here anyway for testing purposes at some point. So I'll just put an empty main function, and we'll say cargo build -- bin tiger beetle. And let's look in our target directory and just actually see. Okay, there it is. So we do have a tiger beetle binary. And we can maybe even look at the linkage of that binary and see if we really picked up that library with LDD, I think. I don't do this that often, so I could be wrong. All right, here's what we linked to. And we don't have the Tiger Beetle library, probably because we didn't call anything in it. Okay, well, hopefully we'll get there today. If not, we'll get there someday. Stash that commit away. And let's try to go do the Bindgen stuff. Now, this Bindgen stuff, let's go review real quickly what we're going to Bindgen. Tiger Beetle client, tbclient.h right here. This is the stuff. So this is the complete interface as far as I know to the Tiger Beetle Zig/C client. Only 323 lines. A few data types, very simple data types. Some structs, very simple structs. That's one of the great things about Tiger Beetle's interface is that everything is flat and simple and compatible, like really easy to understand at a machine level what these things are. And just 5 functions, I think. So I haven't used Bindgen again in many years at this point, but this should all be like bread and butter stuff for Bindgen. But to do it, we're going to have to go remember how to use Bindgen. So let's browse the web some more. I'm going to search for Rust Bindgen, and that should be, I search for Rust Bindgen right here. And I think they've got, their own web page, their whole book. And let's browse this real quick together. And I think I mentioned what Bindgen is. It's just a tool that creates Rust source code from C source code, matching the C definitions with compatible Rust definitions. So we're going to do library usage with build.rs. So we're going to call Bindgen from our build script, which is the common thing to do. You can also call Bindgen once and just generate a Rust file and check it in. But you might not want to do that because your C source code could change or it could be different per platform. So usually in the build script, you'll call Bindgen at build time, just in time to compile it. And what we want to do is, okay, this is all easy stuff. We're going to add Bindgen as a dependency to our build dependencies, so it's only available to the build script. And this create a wrapper H header, not necessary for us. This is just like if you have a bunch of header files and want to collect them all into one thing for Bindgen to analyze. And our build.rs file, so this is the meat of it. This is what we're going to have to do that I don't just know how to do. Mostly this. We're going to call the Bindgen builder, give it our header file. This, tell Cargo to invalidate the built crate. Okay, so this is probably similar to what we already did with our library, where he told Cargo, like, if the library changes, rebuild. This looks magic to me. I don't know what this is doing, and we're not going to go look at the docs. We're just going to copy it. But this is probably the same thing, because Bindgen might be recursively looking through a bunch of C files. And this is probably going to just tell Bindgen to go splat out rebuild commands to Cargo for all of those files. And okay, that. And then after we built the bindings, we're going to bindings.write to file. Okay, so this is some kind of type from Bindgen, and you call write to file on that type to some file. I notice here they're writing to outdir. Outdir is another Cargo environment variable that it sets to tell you where the build output is. So the target directory, it's somewhere in the target directory, but it might be various places depending on configuration. And there's just tons and tons of stuff spewed out there. I don't want to do this at all, actually, because I want to be able to go find the source file that it emits. So we're not going to put it in outdoor. We're just going to put it in our source dir, and then we'll have to git ignore it so it's not checked in probably. That's pretty much it. Oh, one cool thing about what Bindgen is able to do these days is it apparently generates its own test cases for type layouts, which is really cool. So we'll go test that too. And let's get that going. All right, so let's go back to our code. And we need to add it to our manifest Bindgen. We have dependencies here, which is empty. Then we're going to have build dependencies. And normally I kind of just edit this by hand, but Cargo comes with a bunch of commands, and you can download more commands to kind of programmatically edit in the manifest. So I'm going to try that just to show it. I'm going to say Cargo add Bindgen help, because I'm not exactly sure what's next. Right here, section. So you can say add it to, by default, it's just going to add a dependency to the dependency section that we saw. But you can also say add it to the dev dependencies or the build dependencies, which is what we want. Ooh, pretty. Let's go back and look at what it did. Okay, so it updated our crate registry, added Bindgen, turned on some, oh, this is cool. So Cargo is kind of interrogating the dependency we're adding. It added some dependencies. I don't know what pretty please is though. Sounds interesting. Pretty printing for logging, I guess. Runtime, and then a whole bunch of other goop. That's cool. And then it generated the lock file for us. The lock file just locks all the dependencies in place. Great. This looks awesome. Let's go back here and Bindgen. We got Bindgen now as a build dependencies. And let's go ahead and type check that. Cargo is not a command. Hey, Addy Super 94 in chat is asking, is this matte clad? And heck no, I'm not matte clad, and I am sorry about that. My name is Brian. I do a lot of hacking on Tiger Beetle in Zig sometimes, but this project is mostly in Rust. And MattClad is usually streaming Iron Beetle on Thursdays on this channel. And the channel is even called something like Iron Beetle with MattClad or something. But this is Tiger Beetle with Brian. So maybe it's going to be okay, but definitely a different vibe. MattClad is kind of a teacher. He's like kind of giving a lecture about topics. I'm just doing my work on stream, and trying to talk through it. Right now, we're working on Rust bindings to the Tiger Beetle client library, and we're trying to make a Rust client for Tiger Beetle. And I'm trying to do the whole thing on stream, though, of course, streaming and hacking is pretty darn slow. Right now, we're type checking some dependencies we just added. Today, we are just trying to accomplish one thing, and that is use Bindgen to generate Rust definitions of the C header definitions for the FFI API to the ZigTB client library. That was a lot of words. I hope that made sense. All right, and I'm kind of forgot what we were doing, but we type checked that. We got Bindgen as a dependency. And so per our Bindgen docs, we got to go back and edit our build script. And we got all this stuff for linkage. And then the build script, we'll just add next. And to do this, let's go back over to our browser and do some copy paste. I did all these steps. Now we just need, we're going to need path buff apparently. I'll do that myself. All this stuff. Not that stuff. All this stuff. I'm going to copy that. Go back to our terminal. And there we go. Let me see if all that's tabbed correctly. Okay. These comments are, I don't feel like they're, yeah, this is not super informative at this point. This I might keep. Look at this indentation. This is not super awesome. Wow. Because this looks like magic. This is not explaining at all what it's doing, but apparently this is going to do all the rerun if changed for all the source files. Don't need that, don't need that. That's fine. And again, I don't want to use the out dir as I said. I probably want to use a directory relative to cargo manifester. And I also kind of don't want to do two things at once. Let's say out path, and let's not use something so generic. Bindings path equals, what was the name of our variable up here? Cargo manifester, format, cargo manifester. And our manifester is this directory. And we could put our bindings here, but probably we're just going to put them in source next to the other source for this crate. So source is that's fine. I bet I'm not going to need path buff at all, actually. And after this, we're going to put it in tbclient.rs to match the name of the zig/c source code. And here I can probably just say bindings path. And let's see what happens. And again, we can just type check here because the type checking requires running the build script. And this is all part of the build script. So we don't actually have to build the crate, but we do need to at least build the build script and run the build script. And of course it didn't work. Well, this is interesting though. We got some spew from our standard out. libtb client, bindgen x. Okay, here's stuff that Bindgen emitted. Oh, cargo callback. Oh, interesting. Oh, the documentation for Bindgen was not correct. Oh, normally I would go yak shave and submit a PR, but oh, it's deprecated. It's still not correct. It should be cargo callbacks.new, but that's not the error. Let's fix that anyway. That's interesting. What is the error? Process didn't exit successfully. The build script ran, but didn't exit successfully. Panicked in Bindgen. Couldn't find libclang. Okay. Well, the docs didn't say I needed libclang. Oh, yeah, they did. I'm looking right here. Installing clang. All right, you can't see this, but I'm not going to be looking at the web browser very much. We need the libclang package apt sudo apt install libclang dev. Oh, I don't mind if you manage to figure out that password. It's just for this VM. Okay, that should work. Cargo check. Panicked at, oh, all right, okay. Panicked at line 50. Wrapper.h doesn't exist. So apparently I copy pasted bad. Just messing with my windows here. I have so many windows to juggle with this streaming thing. I'm fairly new to streaming, and it's a lot to keep in my head. All right, so my bindings here, wrapper.h, that is not my header. So we need to go find the header path, which means we need to construct it from various environment variables. I'm going to tb client h path. That's an ugly name. Equals format. Probably start from the manifester again. And the manifester, I'm going to back up one, then go down to C. And I think it's in C, tbclient.h. tbclient.h. That should be correct. And we need to put that here. tbclient.h path. Big breath. And it type checks and builds the bindings. Oh, we should have bindings now. Okay, let's check that out. tbclient.rs, 38K. Okay, 768 lines. Great. Let's compare this to our header file. Again, I haven't used Bindgen in a very long time, so I'm kind of excited to see what it's doing. Oh, okay. This is interesting. We're getting a bunch of stuff just pulled in from like the standard C libraries, because these are, transitive dependencies of our tbclient.h. Almost all this stuff is going to be irrelevant. Max line T. Oh, this is. Hopefully it's in like lexical order. So all the C standard stuff will be up here. Interesting. Yeah, I'm curious. That can't be everything in standard def.h, standard int.h, etc. I don't know. Maybe those are probably very small headers. Does it say which headers it's pulling them from? Nah. Anyway, down here, max line T is not it. This stuff is not it. That's a very interesting construct in Rust right here. This const underscore nothing equals a block of something. There's a bunch of const expressions. I am too tired to try to explain this is, but a very strange Rust construct. But very important idiom for certain types of low-level code. Keep on looking for the actual tiger beetle defs. All right, down here we're starting to find the tiger beetle defs. All right, so let's compare. Our uint 128. That's interesting. Tiger beetle has its own uint 128 for some reason. Interesting. Maybe just because that reads prettier than this ugly type. All right. Some enum definitions in C aren't an enum in Bindgen. That's curious. It also didn't keep the same expression for the values, so you can't easily say, well, this is definitely the same as 32. Would be nice if it just like kept this lexical span and just splatted it back into Rust. Though I can understand why it wouldn't. That would be, harder to validate. Interesting, this is not a Rust enum though. Very interesting. Okay, let's keep going. TB account. All right, so it does seem to be emitting stuff in lexical order. So here's TB account in Rust, TB account in C. Very simple struct. Repr C, of course. Align 16, that's smart. So if I was writing this by hand, I would not have put an explicit alignment on this. And just assume that Repr C gave you the same alignment as C. I'm very curious why this is necessary. Derive a bunch of stuff. Okay, interesting. Clone, okay. Yeah, that all looks very straightforward because all these types are very simple types and have very simple corresponding Rust types. Unnecessary operation. Okay, here's a bunch of more. Oh, this is great. So this constant block here is doing some assertions about sizes of the things that it's emitting. So these have to be evaluated at compile time, right? And so, because it's in this const block. And so if these fail at compile time, you'll get probably a very terrible error message about this thing not being right. That's cool. I've never seen exactly this idiom before. I mean, I've seen like static compile time expressions in Rust, but not open coded in this way. That's neat. And it's putting a bunch of clippy stuff on it. Yeah. Okay. These clippy things are just to tell the compiler not to complain about these weird expressions seemingly being useless. Okay, it's all very similar stuff, very similar stuff. Okay, here's different stuff. Here's where it defines the functions. Client init and TB client init. Echo TB client init is up here. It's in its own extern C block, which is necessary to, interesting, necessary to have the right ABI for this function. It's probably also disables name mangling in the binary. Pub function to client. This all looks pretty straightforward. You can see this char pointer, not so straightforward. It's a standard library type, not a built-in type in C. And that's this char star address pointer. context that's on completion. All right, this is ugly. I mean, not as ugly as an anonymous function definition and or a function pointer in C. This is pretty ugly. So on completion, it's a function pointer. Over here, this is a function, which is non-null. So in Rust, all these function pointers were required to be non-null. This is unsafe because it's unsafe. But it's also wrapped in an option to make it nullable. So in C, this function pointer is nullable. In Rust, it's not by default, so you put an option to make it nullable. And these are just called, arg1, 2, 3, 4, 5, 6. Yep, more stuff down here. Oh, this is interesting. So in Tiger Beetle, it defined a TBU int 128 as a underscore u int 128. And then at the very end of this file, Rust defined underscore u int 128. And yeah, that is not in the tb client.h. I'm guessing, yeah, probably Rust was just like, we need this definition to exist, and I implicitly know how to define this. So I just splatted it in at the end as something that was needed. Okay, that was all fun. All right, I'm getting tired, chat. Interesting, though. We've emitted the source code, but we're not using this source code. Don't let me forget that. So here we have to say, call that a module, and link it into our Rust code, our Rust crate. Mod tb client should do it. We'll type check that. Okay, and we got tons of warnings. Wow. Oh, okay. I remember the Bindgen docs had some things that it stuck onto the import of this module to make these kind of things go away. Not FFI safe. That is very interesting. 128-bit integers don't have a stable ABI. That is very interesting. That's kind of a bummer. We need 128-bit ints. We're going to deal with that later. We're going to leave this warning on because that's a problem. I'm sure we can come up with something that is compatible. Or maybe it just works. There's probably a good chance it just works. Let's commit what we've done. And go back to our Bindgen docs and see again what they were recommending about how to actually import this file, because they do something a little weird. Back to the browser. Okay, I think you can see include the generated bindings. This is what they do. And this is kind of a cool trick you can do sometimes in Rust that mostly doesn't make sense, but it's often done for this kind of situation where you just got like a fractional piece of Rust code and you want it to be in your crate, but it's not actually a complete module on its own. This just kind of splats this source code directly into another module. But you can see here it's putting some allow directives on it to kind of make sure it doesn't emit all those warnings about weird looking Rust code. I don't think we need to do this though. This is nice because they're using the outdir, and the outdir isn't a known location. So if you only have the outdir, this is probably the only thing you can really do to include the code. But we put the generated code in our source directory, which means we don't care about outdir. and we can just know exactly where that code is. So I'm going to do it differently, but I am going to take all of these attributes. And what we can do is, on this mod, we can stuff these things, but get rid of these. In Rust, these bangs say these apply to the thing that is encapsulating it. So these apply to the entire module, and putting these here says this applies to the thing that comes next. So this should get rid of all the warnings except for that one really gross warning about 28-bit, 128-bit ints. Yep, there we go. So we're just going to leave this for now, and maybe I'll go and think hard about Google some information about this. Probably, oh, they don't even, a lot of times the Rust compiler will like give you a direct link to an issue on GitHub to go read about something, but not here. I'm sure there's a lot of discussion somewhere on the issue tracker. I don't know how much more I want to do tonight. I haven't streamed too much. I really would like to actually link to this library and call something in the library so that we're definitely linking it into our binary. And I don't think just including these definitions is sufficient. We think we need to call a function. So I think I want to press on and try to call one of these init functions in a not very useful way, and then modify our binary to try to initialize a Tiger Beetle client. All right, so to review, last time we kind of started sketching out some abstractions, mainly this trait, which represents the 5 functions of the Tiger Beetle client, but in Rust, and somewhat rusty, but we haven't really thought too hard about the Rust semantics we want to provide these functions. And in fact, I suspect that what we're writing here in this client crate will not be the thing we present to the public facing API, because the public API is going to be all async probably, and this has no async. So we're gonna have to figure out probably how to wrap all this stuff in an async interface or something. Make it more idiomatic Rusty. That'll probably be another layer up. But for now, we're gonna call this init function, and we have an implementation of the trait down here. So we're gonna call this init function, and we're gonna have this init function call our bindings we just generated and initialize this client. And then we'll be calling something in the library, and that should cause the linkage to finally succeed, and we'll be linking to the Tiger Beetle client library. And again, the reason we have a trait here is because we're going to make 2 implementations of this library. One that is doing what we're doing now, linking to the Zig implementation, but one that's also pure Rust. And we're going to pit them against each other in tests and such. Okay, so I'm really running out of steam, but let's see how far I can get. Let's look at we can probably just look at the Rust definitions at this point. Now let's look at the C definitions. They look cleaner. The Rust definitions are exactly the same. So TB client init is the thing we want to figure out. And you can see here, this out client parameter is a pointer to a pointer. And we're going to pass a pointer, and Tiger Beetle, I assume from what we talked about yesterday, is going to allocate a client and then write back the pointer to that client in this out pointer. So there's double indirection here. And we just store that right here. And for now, all this stuff probably doesn't matter very much. Probably doesn't matter very much. We're just going to throw a bunch of junk in there and see what happens. So in our init function, we're going to call tb client init. This returns status. We're not going to need this status anymore that we defined yesterday because this is defined in our bindings. Oh, I put it right here though. Let's make this for now and we'll figure out later. This is just nil, a nothing type. I'm going to say let status equals this and figure out how to call this function. So we need a client. So let's say let tb client t equals, I want a C null value. Do I have access to that here? This is a pointer. Oh yeah, pointer null. Wow, it's been a while. And that is from the standard library. I'll just call it fully qualified. Standard pointer null should give us a mutable pointer. Because TB client is TB client T, which we also don't need because that should be in our bindings. TB client T itself is a pointer, a void pointer that we're not allowed to look at. And we need a pointer to that pointer. So we got our Rust bindings again, TB client Rust, TB client T. Yep, here it's a mutable pointer to a C void. This is TB client. And I'm wondering whether I should just import everything from TB client, but for now I'm gonna qualify them. And here, this is gonna be TB client equals standard pointer null, yeah. Type inference should figure this all out for us, we'll see. And TB client init, we're gonna say and mute TB client T, give it the pointer to our client. Cluster ID 0. I'm just reading this right now. Address pointer, it's a const pointer to a string buffer. I'm wondering what TB client is going to do if I just pass it a null. I'm guessing it's not going to like it. Let's start with null and just see what happens. I want to see if it asserts or if it returns an error or whatever. Null. Standard pointer null. And this null should probably be null mute, I assume. On completion context, this is a usize. I don't know what this is. I think it's probably a program dependent number for doing dispatch within this callback, but I don't know. I'm going to say 0. I'm going to say 1 just to make it a little different from the other 0 we used. In the completion callback, I'm going to say none, but I'm guessing Tiger Beetle really is not going to be happy with a null callback. That's our status, and we're going to just print that status for now. Status, that's probably just a number. We'll say status. And then if, oh, these are no longer status because I changed these. So these return a status. Oh, right here, TB status. It's a uint that could be any of these things. TB status, TB, ooh, that's a gross name. TB status success. So here we can say if status equals TB client, TB status success, we're all good. Else, we can say, I don't know what level of abstraction we're going to be working at with this trait, but for now, I'm going to just say return. I don't need a return. I can just use an expression. TB return status. And then this is going to be a TB client TB status, which is this type def right here. So this is not great, but it's something to start with. And again, I'm going to put these TB statuses here and also in the trait definition. And let's go look at what we've written here to just think if it's okay. This needs to return something. This is going to be an error of status. And this is going to be okay. Well, let's just see if that compiles. Oh, no, this is this is so wrong. What are we doing here? This needs to return a client. Right now we're initting and then just throwing away the client. Let's go make some more changes. This is going to be, I think we can say self here. This is a trait, right? So there's no concrete type to return here, but I think self works. Again, it's been a while. Init. And here I'm gonna say self again right here. And this okay is going to return a Zig client with client equal to TB client. This shouldn't be TB client T. This is just TB client. Right, there's our TB client. I think that's what I want to write. Let's see if it checks. Cargo, check. Of course not. That's not unusual. Cannot find value TB client T. Oh, that makes sense. I just changed the name of this variable. The size for values of type self cannot be known at comp time. Required by implicit size bound. Implicit size requirement of the type. Result where self is sized. It's been a while again. I don't think this is what I want to write. Don't think this is what I want to write. I think what I want to say is that all Zig clients have to be sized. What is all this stuff? This is previous compilation. Okay, that fixed most of the problems. Cargo check. This function takes 6 arguments. Okay, TB client init. Argument 5. Let's go back and look at. TB client init. Cluster. Address pointer. Address length we didn't put in. So address length is going to be 0 because we tried to pass a null pointer for our address. Can't borrow a thing as mutable right here. That's easy common problem to fix. This is a mutable thing. And call to unsafe function. Yep. Where do I want to put? I have to write unsafe somewhere. I'm just thinking about where I want to put it. Let's put it around the whole function. Okay, that all builds. And again, I'm just gonna checkpoint my work. And let's go to our main and try to call this thing. And I'm guessing it's going to completely blow up because I put a bunch of junk in the argument list. But my goal here is just to link to the library, and then we can probably call it a night. So we need to say let client equals tiger beetle is the name of our crate. I'm going to type that. That's a mouthful. I'm going to say use tiger beetle as TB. TB colon Zig. I'm going to need to import use TB client. I need to import the trait to use it. And then I'm going to say TB Zig client init. Oh, chat. I did something very dumb here. I did something super dumb. So our init function that we need to call in Rust has all these arguments. And in my haste to just get something called, I put dummy arguments here, which is, fine for now. But I should have just written this correctly using the provided arguments, but now I got to provide more stuff here. 0. All right, so again, all these arguments are bogus. They're not even being used. We're just trying to see what happens. That looks bad. Cargo check. Client, that's fine, but we'll quiet it. So this warning I was getting here is that this client argument is unused, and in Rust we can just prefix it with an underscore to say, yeah, I know. Stop bugging me about it. Okay, that checks. I'll say cargo run. I think this will run our binary. Yep, great. So it ran, and it wasn't happy, but it ran and called in the Tiger Beetle. You can see there's a stack trace from Tiger Beetle in Zig. And the stack trace includes our Rust frames too. That's pretty neat. So here's the Rust runtime. Rust runtime is tiny. And it's calling, unfortunately, all the function names are here. Lang start internal, lang start, and then some unidentifiable frames way down there. Then some closure. This is our main function. It's a closure calling our main function. This is all these frames are kind of generated by the compiler to kind of bootstrap the runtime. Rust begin backtrace. Okay, this is kind of a block that generates the scope for future backtraces. Call once, I don't know what that is. And here we're finally in our main function. Oh, this is so nice. Look at all this useful stuff. All right, here's some Rust code. Oh, this is great. You can see Rust code and Tiger Beetle code, and it all works correctly. I'm very skeptical of backtraces. They sometimes work, they sometimes don't work, they sometimes partially work. But here we have two different modern systems languages, and the backtrace is seamless between Rust and Zig. That is fun. I'm happy that it all works. Okay, so the Rust code, you can see, I have no idea what this goop is here on the file name. Probably some kind of content hash. Rust functions and file names are all hashed for uniqueness. We call TB client. We call the TB client export Zig. So we call TB client init in Rust, and it's skipping a frame here probably because it's inlined. No, it's not skipping a frame. This is directly calling. This is the bindings we generate that we're calling, directly calling into Zig. And that's a member function on TB init. And then, it's not happy with our address, of course, because we gave it a null address. And right here, the address count, index equals address count. I have no idea what this is. I'm guessing this is probably didn't check the address for null and continued trying to parse addresses. I don't know. We have to look at it. It's probably checking for null. But yep, hit the address that was bogus. And if we go look at our LDD again, we should see that, we're linking to a static library. So before I was saying, let's look at LDD to see what libraries we're looking for to prove that our Rust program is linking to TB client to the Zig library. That only makes sense for shared libraries, and TB client is a static library. So this is all meaningless. That's pretty typical for me. All right, Steel Tormentor is coding in Zig in Rust at the same time. So that's great. You're learning Zig and Rust. Hey, Steel Tormentor, how long have you been doing both? I'm kind of done here. I'm just chit-chatting for now. We'll see if Steel Tormentor's paying attention. If not, we'll wrap it up. Yeah, I'm glad people have been paying attention to the stream. Just a few people, but it's great that somebody's watching and chatting because I'm a new streamer. I've been practicing streaming for like a month now. It's almost nobody. Sometimes my partner, but mostly nobody. So the last 2 days I've been actually streaming on the Tiger Beetle channel, which has a little bit of a built-in audience, and it's great that right away that people are paying a little bit of attention. That feels good, rewarding. Let's go ahead and check this in. And I'm going to push this somewhere. And we're going to have to force push because we've been just amending our commits. And is there anything else we need to do tonight before we sign off? Again, I'm going to go crash like 5 minutes after we end the stream. But this has been pretty great. Switch back to me. Okay, I don't know if there's all right, so let me tell you what's going on. So I'm streaming this irregularly. I'm going to be doing the whole Rust client for Tiger Beetle on stream, all of it, which means I'm not allowed to work on it if I'm not here at my streaming workstation. And I'm going to be out of town for the next 5 days, I think. I think I'll be back Tuesday. And I'm probably going to be streaming, not every day, certainly, but a lot of days for the next few weeks or months until we get this thing done. Irregularly, I don't have a schedule. So I usually post somewhere 10 minutes, especially in the Tiger Beetle Slack. I'll always post in the Tiger Beetle Slack. Maybe we'll start tweeting it from the Tiger Beetle X, whatever it's called. Maybe other media, but it's going to be irregular. But we're going to be doing a lot of this. So if you're having fun hanging out on this stream, I really appreciate it and hope to see you again next time. This has been great. All right. See y'all later.